Hello, I'm going to go through the AQA GCSE Physics Higher Tier Paper 1 from May 2018, question number 8. Press play and pause throughout the video so that you can work at your own pace. Question 8. Nuclear power stations generate electricity through nuclear fission. Electricity can also be generated by burning shale gas. Shale gas is a natural gas trapped in rocks. Shale gas can be extracted by a process called fracking. There is some evidence that fracking causes minor earthquakes. Burning shale gas adds carbon dioxide to the atmosphere. Describe the advantages of nuclear power compared with the use of shale gas to generate electricity. So you're given quite a lot of information here to help structure your answer and to perhaps give you some clues. So in the first one, you could say there's no carbon dioxide, write it out in full though, emitted with nuclear fission, whereas there is with shale gas. And you could then also list an advantage of nuclear power links to does not add to global warming. Another advantage, well, there's a disadvantage mentioned about minor earthquakes. So you can make the assumption that an advantage, therefore, of nuclear power is that it doesn't cause earthquakes. And something that you may or may not know, but nuclear power, or the rocks that are used in nuclear fission, release loads more energy than what can be done through the burning process. So more energy gets released per kilogram in comparison to the shale gas. For 8.2, what is the name of one fuel used in nuclear power stations? So the most common one to mention would be uranium, or you could have said plutonium. So finally, 8.3, describe the process of nuclear fission. So nuclear fission is all about using uranium, so a large nuclei or nucleus, and splitting it into two or more smaller nuclei that are still probably radioactive, but the advantage is it releases a lot of energy. So that would be a basic answer. But if we wanted to expand on that, we would say that a neutron is absorbed by a nucleus. So we've got a neutron, and then we've got a large bit of uranium or plutonium, and then what happens is that will split into two smaller nuclei, and then we get lots of energy. But something we also get that is often forgotten is we get 2 or 3 further neutrons, and it's these neutrons that can go on and then start the process again, which can then lead to a chain reaction, although in this question that's not required. So to write that out in full, there we go. So this now completes the end of question 8. If you have any further questions, please get back to me.